Hello coders, welcome to my channel Radhe Radhe. Today we are going to study about the two pointer, which is one of the most important data structure that usually used asked in CP or in our OAs of many product company or even in a startup they ask from questions from this topic. So uh, in my channel, I will upload the playlist related to toe pointer. I think 7 to 8 video will be there uh, on two pointer, and if you go through it, your concept will be clear. This is first lecture of two pointer. So before studying about what problem of the two pointer, let's see what is the definition of it. So it is a simple strategy where we use two pointer and traverse the array or a linked list to solve the problem in an efficient way. So now I know that you all know about what is array and linked list, but still I clear about this. Array is used for storing all the or storing the elements. In the same way, linked list do the same thing, but the difference is that the element in the linked list is not stored in the continuous manner. Now, if we see its time complexity is O of n. Usually, our code code will run within 10 to the power 8 time complexity. It will hardly take 1 second. So, so O of n is one of the best time complexity. So that's why many of the coders use to solve their problem. Uh, so now the third thing is that uh, now we see how to check that if the particular question is solved by two pointers. So for this, there's one of the simple hint like when we need to move our pointer in any particular direction, then we use the two pointer approach. Like you can see that in the diagram that I took from the LinkedIn. The first one is the linear search, in which the one of the persons digging from one side. On the other thing, there's a two pointer method. There's a two person from where they are digging. Like one person is from the left side and the other is from the right side. So now if we see that in a linear search, if the person is digging and want to go there where the diamond is present, it will take time because he was working only from one side, while in the other way, there are the two persons working, so it will consume less time to go where the diamond is present. So that's why we use the two pointer approach because two pointer makes our program efficient. And so yeah, that's the all about the simple thing that how what's two pointer and how it is used and so on. Now we can place the pointer in a two different way. You can get about all these things like when we use these two cases, when our question will take this case and when will take this case. This depend on your practice. If you practice more, you will know about that. So if we see the first case in which one point will be slower and other will be faster. So in the first case, one point will move in a slow, and other will be moved in a fast way. It means that one pointer will move one step, and the other will move two steps. So this is one of the case. And the other case is the one pointer will be pointing at the start of the element, and the other will be pointing the end of the element. So the first question that we are going to solve, because we know that. To have a better understanding of any topic, we have to practice a question. Practice question a lot to know about that. The first question that I have taken is a two sum. This is one of the most simple question. But as we know that we have this is for I'm teaching for a beginner, so we start from the simple and easy problem that is two sum, in which we use the second technique that one pointer will be point the beginning and the other will point the end of the element. So this is the this to so moving ahead, we can find this question in our link code. So here first we read the question that we have given an array of integer num and an integer target. We have to return the indices of two numbers such that they sum up to give target. Means the question, what some question is saying that we have num array and we have a target. Okay, so we have to find two number such a way that if we sum up these two number, it gives us the target value. For example, as it given that 0 1, this is the indices because we have said that we have to return the indices, not the value. That's why here 0 1 is given. Like in here 0 means 2 and here 1 means 7. So if we sum up 2 and 7, it gives 9. That's why 0 1 is the answer. In the same way, we have 6. We can see that if we sum up 2 and 4, it gives 6. So indices of 2 is 1, index of 4 is 2. And in the third case, we have target equals to 6. So if we sum up 3 plus 2, 3, it gives 6. So the indices of first 3 is 0. The index of second 3 is 1. So 0 1 is the answer. So the one of the brute force approach that we are the coming in our mind is the is simply the for loop. Like we will use we will use for loop. Like let's see from one example. Like first loop we will use do loop. I will be point here, j will point one step ahead from the I. So j will point here. First we take 3 as 3, and then we'll add 3 with 2, then add 3 with 4. In the same way we'll take 2, then add 2 with 4, and in this way we will reach to the last index and our loop will end. And if we adding the same the thing, if we find that the sum of 2 is equals to target, then we will return that indexes. So this is a simple approach, and the time complexity that it will take is of n square because we are using two for loop. And the space complexity is simple because we are not using any space, so it is a constant of 1. Of 1 will be the space complexity. Now, so this is a brute force approach that we all know, but and we can see the constant is also not so much high, so it will pass all the test cases. But we have given a follow up. You can see in the below that you can come up with an algorithm that take less than of n square time. So it means it's saying that we have to code in such a way that the time complexity will be in O of n something. So that's why we are using here the two sum approach. Now why we are using two sum approach, you will find when I explain the question. Okay, so let's see. We have given 2 7 11 15. So now we have to sort the array because in the third point we see that yeah, that we can move the pointer only in a particular direction, either in not in a particular direction but in some manner. Like here the pointer is moving, the first moving in the right direction, second is moving in the left direction. Not like that first time it moving in right, then again moving in left, not like that. So that's why we use the two point approach here. Okay, so first we'll point here, I will point here, j will point here, and before pointing we will short the array. Okay, and then we sum up a of I and a of j. That is means a is the array, name of the array right now. Then 2 plus 15, what we if we do 2 plus 15, we get 18. Sorry, it's 17. So and we can see that our target is 9 and 17 is very much higher than the target. So now what will we do? Which pointer should I move, I or j? So here in this initially we have sorted the array. So it means if we need to make the sum smaller, we need smaller number of values, like we need a smaller nums I or nums j. Here we have getting more greater number than the target. So moving I will will make the sum more larger because we have larger number in the right side when we are going from left to right. To make the smaller, to make the sum smaller, we will have to go from the right to right to left side, means in the left side, because we have sorted that in ascending order. So if we have defined 15, it is obvious that there is a smaller number than 15, that is 11. So if we sum up 11 and 2, it will give the number which is smaller than 2 and 15. So that's why we are moving G pointer. uh, if you are not getting again I will explain, like you can see we have two 7 and 11. We have 2 7 11 and 15. Now if we sum I and j, if I is here and j is here, so 2 plus 15 gives you the number which it gives. It will obviously it is greater than the number which it will be given by 2 plus 15. 2 plus 11, one number which is ahead of this, before this one, because our number is in a ascending order. Okay, so 11 is greater, 11 is smaller than, obviously 11 is smaller than 15. So if we sum up 2 plus 15, it will give it will give 17. If we sum 2 11, it will 11, it will give 30. So that's why we are moving the G pointer on the on the left hand side. So again, what means I say, I think, like we have given a number, this is some another number I have taken. I is here, j is here. Okay, so we have an ascending, we have sorted in ascending order. It means the number which is present here, it is smaller than the number which is here. Okay, so if we make 2 as a constant, we make 2 as a constant, then if we add 2 with 3 and 2 with 4, so 2 plus 3 5, 2 plus 4 6. It means that it is obvious that 2 plus 3 is smaller than 2 plus 4, because 4 is greater in the number. So that's why, to make the number smaller, we will take the number from the left side. That's why if the sum that we are doing is become greater, so we will move the j pointer. In the same way, if our sum will be become smaller, to increase the sum, we will move our I pointer in a right direction. So this is the thing we have done. So the in the question 2 7 11, I will be here, j will be here. Okay, so 2 plus 15 we are getting 17, which is much greater than our target. That's why we will move the j pointer here. The j pointer here we will move. Now we will see the 2 plus 13 is will give, if 2 plus 11 is 13, which is also greater than our target. Then again we move the j pointer in left direction. Now j will be here. Now 2 plus 7 we will move. It will give somewhat 9, which is 9, and our target is also given that it is 9. So in this way we will return 2 and 7 as a value that will summing and giving up the as the target. In the same way we have 3 to 4. Now to take, let me take some bigger example to understand more. um, we have 7 3 1 2 and and 4. Now we our target is to find 9. Our target is to find 9. So according to our algorithm, first we need to sort the array. So if we sort the array, it will become 1, 2, 3, 4, and 7. 1, 2, 3, 4, and 7. Now another in the second step we can see, first we make sort the array. In the second step, we have to allot the I and j pointer and then add up them. So I will be here and j will be here. So if we sum 1 plus 7, it gives you 8. And but what are our target? Our target is to find 9, and 8 is smaller than 9. So in this case, we need greater sum. So we will not move j pointer, we will move I pointer because we need greater sum, and we will find greater element on in the right side. That's why we increase the I pointer to k in 2. So if we sum 7 plus 2, that is 7 plus 2, 7 plus 2, it gives you 9. And in this way we find our target. So if we get our 9, and then we will return our point, return the indices. So this is the case that this is the way on an algorithm that we will use to sort this to some pointer approach. Okay. So let's see its algorithm. Like what I have said, that's the same thing I have done here. That first we sort the array, then I sum up the number, and in the third step I take this, I see that if d is greater than target, it means we need to find the smaller sum. That's why we are moving j into j minus minus. And in the step 4, if we find that d is smaller than the target, it means we need the sum more. We need more sum. That's why we were moving I pointer. Or and the last, that if we find d equals to target, that is great that we are finding, because we are finding that only, then we will return true. Here I am returning true, but in the question it was saying to return the indices. Okay. So yeah, this is the algorithm that I use in my code. So now for better understanding, let's see my code. What, like, now I think you have noticed or not, I don't know, but when we are sorting our array, you can see that we are losing our indexes. That in the original our index will be, index of 2 is 0, index of 7 is 1. But when we are sorting, its index will be changed. Not in this case because this is already in a sorted form, but you can see this in the 3 to 4. In the 3 to 4, that if we are sorting, it becomes 2, 3, 4. The indexes of 2 become 0. So, so to avoid that situation or a hurdle, we use the pair vector with a pair, where pair will store number with its indexes. Like you can see in my comment what I have written, that the original indexes are lost, so we use the vector of pair. In each vector we store num psi, that is value, with its indexes. So yeah, so here we, as I said, I made a vector with pair, and will include denoting the nums size. Now first we will fill the vector with the sum, with the number and the indexes. So I'm taking one loop, for loop I equals to 0, I smaller than nums the size. You can write n here also, I forgot to write that. Then I plus plus. Now we push nums I with its indexes, nums I with indexes. Okay. Now we will sort the vector. We will sort the vector that I have made. Now you think that if we sort, we will again lost the indexes. No, we will not, because we make it spare, so it will not lost. Okay. So yeah, so this is done, and after that we in a slash to point the I and j. As I said that I will point in the first side, in the leftmost side, and j will point the rightmost side. So I equals to 0, j equals to n minus 1. Now the again, how many time, and what is the break point. When will be our algorithm break? It will break when our I become here and j will goes to here, means they become j I become greater and j will become smaller. So in this case we will break our pointer and we will break our algorithm. So yeah, the same way first I sum of the sum of the two pointer, because vector but first denote the first element that I stored in the vector of pair. Okay, so we have some of these things. Now we use three test cases. As I said that here we have three cases, 1, 2 and 3. So um, first one is the, if we find sum equals to a target, then in the same time we will, on that instant we will return the vector indexes, because we need the indexes as said in the question. So yeah, that's it. Now if the target becomes smaller, we will do I plus plus as I said, and else become j minus minus. But if we find that there is no number for sum giving us the target, then we will return minus minus, because this is the case when we will not find our numbers, then we will become minus minus. So now if we run the code, you can see that it is passing all the case cases. Now let me submit it. So yeah, you can see that my code is accepted. So now this is the approach. This is how you will approach. Now if you see time complexity, you can see that there's uh, one for loop is used here, that is O of n. It will take O of n, and then we will again see that another for loop is used. It will also take O of n, and if we sum of this two, we will get 2 into O of n. 2 into O of n, this is constant. That's why we will neglect it and it become O of n. So we have solved the question in O of n time, because and it in the follow-up is also saying the same thing. We have to make in a less than O of n square time. So this is the way. Now if we talk about the space complexity, it will take O of n, because it is not constant here, because we use a vector pair to store the original indexes. So that's why space complexity will be O of n, because we are using the one of the vector pair, and time complexity will also be O of n. So in this way we have solved our question in an efficient manner, and this is passing our test case also. So so this is one of the first problem in a LeetCode 2 sum problem. Now if we move to our PPT in a Google Doc, we have another problem also, the three sum. It is very much similar like the two sum problem. That's why I have took this one also, so that it will create a pattern for you to, so that you will remember the questions and the approach. So like here what we have used, the same thing we have done in the three sum, just we here there's a slight difference. Here we use the three things, because what the question is saying, uh, let's see. So here the threesome problem. It is a medium problem in the LeetCode marked as medium. So don't afraid by saying only it's medium. The algorithm is just same like what we have done in two pointer of two sum. So here we read, we given integer num return all the triplets. We have to return triplets here such that I not equals to j, j I not equals to k, j not equals to k. It means that not we are not take itself the number and sum up with itself. Okay, so this means like so this is a thing means we don't take I, j, k as the same thing. Now we need nums I plus nums k equals to 0. So this is a question that is saying that we need three now sums, three numbers in our numbers, and when we sum up these three, it will give 0. Like here we can see we have given minus 1, 0, 1, 2, minus 1, 4. If we sum up if we sum up num 0, nums 1, nums 2, that is minus 1 plus 0 plus 1 gives you 0. So this is one of the triplet. Another one is nums 1, nums 2, nums 4, that is 0, 1, minus 1, 0. So it's giving so in the same way, but it means we need three number. When we sum up them, it gives 0. But what have said is here, we need two sum which sum up gives you 9. Only the change is there here is that we need extra number and we need extra number here and uh, if not equals to target it equals to 0. So just there's just a slight difference in it. So again so again so let's see the question. We have given, let me cut it out otherwise I will be confused. Minus 1 0 1 minus 1 0 1 2 minus 1 4 2 minus 1 4 minus 4 sorry. So as we see that first we need to short the array. So if we short it will become like 0 minus 1 minus 1 oh sorry minus 1 will be in the array then 0 then 1 then 2. Oh, minus 4 is also there. Minus 4 will be here. Let me cut it out. I messed up. If we short this one, it will be become 1 0 on minus 4 minus 4 minus 2 two times minus 1 two times then 0 1 2 0 1 and 2. Now we need we need three sum of triplet. So I and J is the same like I will consider will be in the left side, J will consider from the right side. But now what about K? Because we can see that K will here K will we will take K as a first term. Here it's saying I is the first. I am saying that I'll say that we will consider nums K as the first term. So if the K will be here, we will put the K will be here. So it means I and J will be in this range. I will be J. I and J will be in this range. That's why J will simply J is no there is no condition for J. J is simply from the n minus one. But I is from one step ahead from K. I will be here. So that's why we will point K here. J is one step ahead from K. I is one step ahead from k and j is simply from n minus 1. So the same thing I have done here. Like first we sort the array. We need three elements sum. So we use three variable k, I, j. K will point the first element, I, j will point the second, third respective element. That's why if we consider k, so I and j will be in here, or else if we consider k here, if it is a k, then I and j will be here. Okay. Now we use the loop for k, just same like we have done in sum, and take y and j from I from the left side, j is from the right side. So yeah, same thing is taken what I've said, that we will take I like from k plus 1 because k is the first element, so I equals to k plus 1 and j is simply from sum of size minus 1 and size minus 1. Now in the step 4 we have in in these two sum we add two elements. In three sums we add three elements. Three elements nums k, nums I, nums j. Okay. Now again we will see if the sum is greater than if the sum that is d is greater than 0, it means we need smaller than what we have. So that's why we'll move j minus 1 is, and if it is greater, then we will move I plus plus. And in and the last one, that is the base case, that if we found d equals to 0, then we'll simply push into the pair, and then we'll return that pair. So this is a simple thing we are doing in the question in the code as well. Like I made number n of size number, then vector of vector, because we have to return the all the numbers I, j, k, which are summing and giving us 0. That's why I need vector 2D vector. Then then the same thing that we have done in the first step, we are sorting. Then in the third step we are taking k from 0, k equals to n minus 2 and k plus plus, and I is from one step ahead from k and j is from n minus 1. Now one question arises, why we take n minus 2? Because see, if we have pointer, if we if we want the last pair which is giving us, which is last three sum element which is giving us 0, so it k will be here, I will be here, I will be here, and and j will be here. So, the last step that k will move is from n minus 2, because these two will be occupied by I or j. Means if let's say k will take here, then I will be take here. So where will the j? Where will the j will go? Because after that we have nothing outer, because we have the fixed length of array. Okay, so that's why k is from n minus 2. Now again we used for loop that we have the same way we have used in I or j through sum. We summing the all three, then we're checking if the sum is equals to 0, then we will push, because we don't need here we don't need only the indexes, we need that values as well. So we are pushing all three values in the answer array. Then we're moving I and j as well, because we need another pair. That's why we are moving I and j. Now, if we are getting sum smaller than 0, we need much greater sum. That's why we are plussing. And else, if we are getting greater sum, we will making it smaller, as close as possible to 0. That's why we are doing j minus minus. Now, here the extra thing that I have written, because it's saying that notice that the sum set must not get elements. Okay. So to avoid duplicate things, we use the set, because we know the set is used for handling the duplicate things. So here we use the set and push all the elements of the vector in the result set. Name of the set is result set, and after then again we are assigning that set's value in another vector, that is answer, and return that answer, and still giving us the giving the answer. So if we submit it, you can see that it will pass all the test case, I hope. You can see that all the test cases accepted. So this is one of the good way to solve three sum problem. So now if you want to see, wait, now if you want to see the number time complexity, you can see that we are using one for loop here, one for loop is here, and another for loop is here. Okay, so I think it takes of n square time, because we need first from his this side, and your first will be k will be the first loop, and then I smaller than j is the second loop. It will be O of n square. This is the time complexity, and it will pass all the case cases because our constraint is very small, so it will pass all the case cases. There are many other way to solve this question, but with two pointer approach, two pointer, this will be solved by using two loops. You can make this code in an efficient way by using other data structure. You can do that, but since we are learning the two pointer, so I'm showing how we can handle this question with the two pointer also. Now, so yeah, this is the test case. This is the two question that in today's video I have covered, and you will get the notes in the description. I will provide this in the description, and in the next lecture I will solve other questions. Other question of different pattern, like you have seen that here the two question is depends on this pattern, that one is indicating the beginning element, and other is indicating the last element. So in this way we have solved these two questions. In the other upcoming lectures, I will provide different questions of two pointer with a different approach, and and notes will be provided in the description. So, or here's my LinkedIn profile. You can see my name is Kumari Nisha. You can search me on the LinkedIn and follow me. Uh, uh, Follow me so that I can make my connection more. So I hope you like my video. This is my first video I'm making and posting in YouTube. If you find this helpful, please like and share and subscribe. Thank you.